All right, welcome back. We are in Chapter 10, Probability, discussing Lesson 9, Probability of Compound Events. So with all the problems that we're going to discuss today in this guided practice, you need to use an organized list, a tree diagram, or a table to solve. Okay? So let's go ahead and look at Problem 1 and solve Problem 1 together. So you have 4 tickets to the movies and can take 3 of the 4 friends. So the 4 friends are Mike, Tom, Eddie, and Chris. Okay? If chosen randomly, what is the probability that you will take Mike, Tom, and Chris? So what's the probability? So that's what we're trying to find, is the probability that you'll take Mike, Tom, and Chris. Okay, first let's go ahead and state our variables. So Mike is going to be M, Tom is going to be T, Eddie's going to be E, and Chris is going to be C. Okay, so I think what I want to do is I'm going to use a list for this. So I'm going to start with Mike, and I want to write all of the outcomes that Mike is a part of. So I'm going to write Mike as Mike being one of the 3 chosen people. So it could be Mike. I'm going to have Mike partner with Tom. So I'm going to write all the options. So Mike, Tom, Eddie, that would be 1. Or we could have Mike, Tom, and Chris. Okay. Now, there's no more options with Mike and Tom being a partnership, so I'm going to switch that up and have it be Mike and Eddie. So Mike and Eddie, which would have to be Chris right there. So Mike, Eddie, and Chris. Those would be the options for Mike going, at least being the first choice. Okay, so but the choice doesn't matter. The order for this doesn't matter. So now let's go to Tom. So let's look at Tom. So 1, I'm going to partner Tom with Mike first. So it's going to be Tom and Mike. So it's going to be Tom, Mike, Eddie. And then it could be Tom, Mike, Chris. That would be another option, Tom, Mike, Chris. And now there's no more options for that particular partnership. So I'm now going to partner Tom and Eddie. So it's going to be Tom, Eddie, and Chris. Okay, so those are all the options with Tom being first. Now I'm going to move on to Eddie. So for Eddie, I'm going to have Eddie and Mike be in the first partnership. Mike's going to partnership with Eddie. So it's going to be Eddie, Mike, Tom. And then we can have Eddie, Mike, Chris. There's no more options with Eddie and Mike being a partnership. So I'm going to have Eddie and Tom be a partnership. Eddie, Tom, and Chris. All right, so those are all the options for Eddie. Now I'm going to move on to Chris. So I'm going to have Chris partner with Mike. So it's going to be Chris, Mike, and Tom. And then I'm going to have Chris, Mike, and Eddie. And then Chris, Mike. There's no more for Chris and Mike being a partnership. So I'm going to have to partner Chris and Tom together. So it's going to be Chris, Tom, and Eddie. Okay. So now at this point, we need to cancel out any duplicates because there are some here. So for this one, Mike, Tom, Eddie, that would be the same as Tom, Mike, and Eddie. So that one cancels. And what else would we have? Mike, Tom, Eddie. I think there should be another one. Yeah, right here. EMT. So that's the same thing right there. So that's a duplicate, so we can cancel that out. So let's go ahead and go to the next one, which would be Mike, Tom, and Chris. I see Tom, Mike, and Chris, which would be the same, or Chris, Mike, and Tom, which would also be the same. Okay. How about Mike, Eddie, and Chris? That would be the next one. Mike, Eddie, and Chris. And we have Eddie, Mike, Chris, which is the same, and Chris, Mike, Eddie, which is also a duplicate. So we have now completed all of these. So we can move on to the next one here. Tom, Eddie, and Chris. And that would be the same as Eddie, Tom, and Chris. So that's a duplicate, or Chris, Tom, and Eddie. That would also be a duplicate. So we are ready to figure out, now we're done with this one, our probability. So our probability that we would take Mike, Tom, and Chris in any order. So that's going to be the favorable outcomes over the total number of outcomes, right? So the total number of outcomes would be 1, 2, 3, 4. There would be 4 outcomes. And the favorable, so do we see one where we have Mike, Tom, and Eddie? I mean, Mike, Tom, and Chris. This is Mike, Tom, and Eddie, so that wouldn't be it. Mike, Tom, and Chris, there's one. Mike, Tom, and Chris. And this one doesn't have Tom, and this one doesn't have Mike. So there's really only one favorable. So the probability of getting Mike, Tom, or Chris is really 1/4. Okay? So that's how that problem would work. So now I want you to go ahead and try number 2, but we're going to go ahead and set it up together first before we start it. So problem 2 says 10 seniors are on Coach Abel's basketball team. She is going to randomly select 2, okay, so she's selecting 2 of the 10 seniors to represent their team at a regional all-star game. So what is the probability that she will select Megan and Jordan to represent the team? Okay. So let's go ahead and define some variables before you get started with this particular problem. So there's 10 seniors, right? So there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm just going to say that this is going to be, I'm going to call this person, we don't know, the only 2 names we know are Megan and Jordan. And so I'm just going to call this A, B, this person C, D, E, F, G, H. And then at the end, we're going to have M for Megan and J for Jordan. Okay? So you need to go ahead and make a list, a tree diagram, or a table to find all the outcomes, and then from that find the favorable ones, and find the probability. So here's my friend the Pause Dragon, remind you to pause your device. Go ahead and work this problem out. When you get done, press play and we'll talk about the answer. All right, see you in a bit. Okay, we're back. I think I'm gonna try, let's see how you did. I'm gonna try a list for this one. So I'm just gonna go with, there's only 2, so I'm gonna start with player A and put them with B, and then go A with C, A with D, A with E, A with F, A with G, A with H, A with M, and then A with J. Okay, so those are all the options with A being first. And then I'm going to go for B. I'm going to go BA, and then BC, BD, BE, BF, BG, BH, BM, and BJ. Okay, after all the options for B, I'm going to head over to C. And I'm going to go CA, CD, CA, CB. I'm sorry, it should be B, CB. So CA, CB, CD, CE. Okay, so I went CA, CB, CD, CE, CF, CG, CH, CM, and CJ. All right, So those are all of C's options. Now I'm going to go ahead and move on to D. So it's going to be DA, so DA, DB, DB, DC, DE, DF, DG, DH, DM, and DJ. All right. Now I'm going to move on to, we have all of them for D, so I'm going to move on to E. And I'm going to go EA, EA, EB, EC, ED, EF, EF, EG, EH, EM, and EJ. Okay? And after E, I'm going to move on to F. So it's going to be FA, FB, FA, FB, FC, FD, FE, FE, FG, FH, FM, and FJ. All right, so I have all the ones for F. So now I'm going to try G. So I'm going to start with GA, GA, GB, GC, GD, GE, GF, GH, GM, and GJ. All right. Now I'm going to move on to H. So HA, HB, HC, HD, HE, HF, HG, HM, and HJ. How are we? Okay. Then I'm done with H. I'm going to move on to M. So it's going to be MA, MB, MC, MD, ME, MF, MG, MH, and MJ. And now for the last one, J. So JA, JB, JC, JD, JE, JF, JG, JH, and JM. So that is all of them, but there are some duplicates, right? So we need to cancel out all the duplicates. So let's start here with AB. BA is the same as AB. AC, CA is the same. AD, DA is the same. AE, EA is the same. AF, FA is the same. AG, GA is the same. AH, HA is the same. AM, MA is the same. AJ, JA is the same. All right, so we have all of those. Those are all accounted for and done. So let's go on to the next column. BC, CB is the same. BD, DB is the same. BE, EB is the same. BF, FB is the same. BG, GB is the same. BH, HB is the same. BM, MB is the same. BJ, JB is the same. So now we have all of these outcomes complete. This is a part of our total outcomes. Let's move on to the next column, CD. DC is the same, CE, EC is the same, CF, FC is the same, CG, GC is the same, CH, HC is the same, CM, MC is the same, CJ, JC is the same. So there we have that. Let's look at the next one, DE. ED is the same, DF, FD is the same, DG, GD is the same, DH, HD is the same, DM, MD is the same, DJ, JD is the same. Okay, so those are done. All right, let's go on to the next one. EF, FE is the same, EG, GE is the same, EH, HE is the same, EM, ME is the same, EJ, JE is the same. So we have all of these additional outcomes. And we go into the next one, FG, GF is the same, FH, HF is the same, FM, MF is the same, FJ, JF is the same. Okay. And then we move on to GH. HG is the same, GM, MG is the same, GJ, GJ, JG is the same. Yeah. Okay. Then we are at HM, which is MH is the same. And then HG, HJ, which JH is the same. Okay, and then we are at MJ, which means JM is the same. So now we are ready to find our probability because we have all of the outcomes listed. So to find our probability of Megan and Jordan, right? That's going to be the favorable outcomes over the total outcomes, total number of outcomes. So we can figure out the total number of outcomes now. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. So there's a total of 45. I'm just going to go ahead and recount that. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. All right, so now we just need to find the favorable. So what is the probability that she'll select Megan and Jordan? So which ones of these have Megan and Jordan included in them? So we should just go to the Megan Jordan. This is it. There's only one, right? So there's one favorable. So that means the probability of Megan and Jordan going would be 1/45. All right, if you got that right, awesome job. Okay, let's move on to the next page. Problem number 3. And I want you, well, let's go ahead and talk about it first. You are knitting a hat and you want it to have 2 different colors. So it needs to have 2 different colors from the 3 color choices. So there's red, black, and blue. You randomly select the yarn colors while you knit. What is the probability that the first color is blue and the second color is red? So first we need to define our variables. So red is going to be R, black is going to be B for black, and blue is going to be, we'll call it U for blue. Okay, there's a lot of U sound in there. All right, so there we go. That I just wanted to find your variables. So now we just need to go ahead and you can make a list, you can make a tree, but I want you to go ahead and work this problem out. So go ahead and pause your device. When you figure it out and you get the answer, press play and we'll talk about it. All right, we are back. We are trying to find what is the probability that the first color is blue and the second color is red. So since we're talking about first and second, I think I might just do a a tree. I think I'm going to do a tree. Okay, so I'm going to start with red. Red is going to be my first color. So for my tree, I'm going to have red. So it's going to be R. That's going to be first. Oh wait, you're knitting a hat and you want it to have 2 different colors from the 3 color choices of red, black, and blue. You randomly select the yarn colors. Well, I don't think I'm going to actually do a tree. I'm just going to list them because we're only talking about 2 colors. So we could do red and black, or we could do red and blue. That's really it for that. Okay, so never mind on that. Then let's go to black. I mean, what are our choices for black? We could do black and red, or we could do black and blue. Okay, and then we're on to blue. So for blue, we could do blue and red, or we could do blue and black. Okay? So this wants to know, what is the probability that the first color is blue and the second color is red? So for this one, the order matters. The order of the letters matters because it wants to know what's the first color and the second color. So here, when we have red and black and red, these are not duplicates. This means that red is first and blue is second. And this, I mean, black is second. And this one means black is first and red is second. So the order matters. So whenever you have the order mattering, that is talking about a permutation. So this is a permutation. Yes, it is. So let's go ahead and find the probability. We can find the probability. So the probability of, oh man, this is a lot to write. Probability of the first, I'll just say first is blue, and the second is red. So we're going to find that by taking the favorable amount of outcomes and dividing it by the total number of outcomes. Okay, so let's look at this, and we can figure out the total pretty easily just counting them up. 1, 2, 3, 4, 5, 6. So there's a total of 6 outcomes. Now we need to figure out which one's favorable. So which one is the first color, blue, which we're using U, and the second color is red? Well, there's only one option for that. So that means our probability of the first one being blue and the second one being red is equal to 1/6. So if you got that one right and you wrote your list, awesome job. Okay, let's move on to problem 4. Problem 4 states that Martin randomly selects 3 days of the week to work at his uncle's farm. Okay, so 3 days of a week. So only 3 days of a week, okay? What is the probability he selects? So we're trying to find the probability that he selects Monday, Friday, and Tuesday in any order. So that, in any order, that means that the order does not matter, which means we're dealing with a combination, okay? So we need to find the probability, so you need to list them all out so you can find that total number of outcomes and then determine what the favorable outcomes, and then you can find the probability. But first, before we do that, let's go ahead and define our terms for the week. So there is Monday, right? We'll call that M. Tuesday, we'll call T. Wednesday, oh, I should have put that in parentheses, right? Wednesday, we'll call that W. I don't know why I started the week with Monday. It should be Sunday. But I still have room. I'm going to make it Sunday. So we'll go Sunday here. and that's going to be an S. So Sunday, Monday, Tuesday, Wednesday, Thursday, or is it Monday, Tuesday, Wednesday? I don't know. Yeah. Okay, Sunday, Monday, Tuesday, Wednesday, Thursday, and we're going to use an H for Thursday. And Friday, I'm just going to say Friday, and we're going to use F for Friday. I'm running out of room. And Saturday, what will we use for Saturday? Saturday. Let's use a D for Saturday. Okay, D for Saturday. Okay, Saturday. Okay. So, Martin randomly selects 3 days of the week to work. So we have to write all the 3 combinations for this. So let's go ahead and start with Sunday. Let's start with Sunday. So we could have, okay, let's start. Let's get it going. Okay, so we could have Sunday. I'm going to have a partner be Monday. Okay, so it could be Sunday, Monday. Those are going to be partners. It could be Sunday, Monday, Tuesday. Or it could be Sunday, Monday, Sunday, Monday, Wednesday. Or Sunday, Monday, Sunday, Monday, Thursday. Or Sunday, Monday, Sunday, Monday, Friday. Or Sunday, Monday, Saturday. Okay? So those are all the partnerships with Sunday, with Monday partnering with Sunday. Now let's go ahead and find the partnerships with Sunday with Tuesday. So Sunday, Tuesday, Wednesday. Sunday, Tuesday, Thursday. Sunday, Tuesday, Friday. And Sunday, Tuesday, Saturday. Okay? So those are all the outcomes with Sunday being partnered with Tuesday. What about Sunday with Wednesday? So we would have Sunday, Wednesday, Sunday, Wednesday,